The last topic we discussed is the water system and including water supply system. And I mentioned in the first lesson video of today class, water system apply in construction site for multiple ways. First, we need to dewatering when you do the substructure work like plumbing, foundation, footing, basement, all of that. We need to dewater. That's something that show the project near our areas, and you can see here in the this project at the uh, in the Three Oak Parkway and just opposite side of our campus, and you see the water pump out to do the substructure work for this project. And that if go to this one, I just give a short overview this during the prepare for the grading, all of that. You see the piping have to be water, otherwise during the rainy season here, water it will be all over place, so that we have the pumping system to maintain, of course, including the retaining areas. And that you can see that from here is the pipe, so that they can pump the water out with pumping, air compressor, all of that with, of course, other equipments that we discussed earlier. So that need to have water system. The other water supply, we need water to provide for compaction of all of this material, to paving concrete, all of that. It need water, cleaning the equipment before they go out the site, for the environmental aspect of that, of the neighbor. So that need water. So that we discuss in here. So in that system, and same as fluid mechanics, we talk about the head instead of pressure drop in air, compressed air. We talked in the previous lesson videos. For the water, we talk about head. To maintain the required head so that the water can pump out or provide the enough pressure for use, then the equivalent height of a column of water is defined at the head. What is the equivalent height of the column of water? And to determine the required head, those equivalent height have to be greater than the sum of static head and the friction head. So the loss due to friction through the pipe, through the fittings, through the hose, all of that we call friction head. And friction head process, we determine it similar to we determine the pressure drop or loss in compressed air that we work in problem 2 in today's lessons, and the concept in the first video of today's lesson use different tables. But for the water, we use 9.7 table. For the pipe, 9.8. And then the finger for the equivalent length of the fittings with the with a different type of fitting, determine the equivalent length for the pipe. When we determine friction loss, that go to the same figure that we use for compressed air, which is finger 9.4, available on the reference on the slide as well. So that's the first thing, what is required head for that. When we know the required head, we can determine the pump. We can select the pump so that it provides the water pressure sufficiently for the use, regardless of that is used for dewatering or provides water for the job. And the capacity of the centrifugal pump, which is typical use in construction, that is a function of pump size. So the volume, how many gallons per minute we need, the horsepower, the total head required, how to set up that, how high we need to pump the water up, then the elevation of the pump relative to the ground, relative to the discharge. So those are the variables that need to consider when we determine the capacity of the centrifugal pump. And that go to table 9.9. We can determine what is the M-rated pumps that meet the demand with the pump size, with the pipe size, etc. And that, let me go to those table 9.7, 9.8, finger 9.4, and of course with the table 99, and then we go to problem 3 shortly. So first, as you can see, we use the same finger to determine the equivalent length, that is finger 94, and then go to the friction head loss in pipe. So use 97, and that a function of what? First the flow, gallon per minute, and then what is the pipe size. So it's similar to compressor, but use different finger for the water for pipe. And for the hose, do the same, 98, so that we can do what is the flow and what is the hose size. Basically the nominal diameter. We can determine the head loss through the hose. And for the pump selection, as I show you the project near our areas in the on the Three Oak Parkway and Pie Chase Road, that still under construction at this point we are talking, and they need the water dewatering, and in that case also need what is the pump we need to select given the multiple variables that I just mentioned earlier. So here for this table and the next slide, also the same table 99, that determine the model for amp rated pump. So you have model 5, model 8, model 10, model 7, and the next slide we have model 15, 20, 40, 18, and even bigger size 90, 200, and 125. So bottom line, first we need to select which pump needed. Then it based on what? The first is what is the friction loss, total head loss, including frictions. And then we will determine what is the height of the pump above the water. So the water table here. The pump, where is the pump, and how that high compared to the surface water that they want to discharge the water. So that is also a function we need to consider. So from that one we can determine the minimum capacity, gallon per minute for rated centrifugal pump. So as you can see here, for example, if the total head including friction loss throughout the pump, throughout 15 holes, is 40 feet, and we need the height above of the pump above the water is 10 feet, then with that the minimum capacity needed in this case is 71 gallon per minute. So similar process we do for other models.